But without any further ado, I would like to introduce our next speaker, Falcon Momot. Please give him a warm ShmooCon welcome.
Well, thank you. Good morning. Well, Seattle morning anyway. This is a talk about defensive systems. On parsing Manifesto, essentially this, the topic here is another one of the language theoretic approaches that I've spoken about here in prior years, but just going into a touch more detail on what we might do to try and deal with the parsing and injection issues that have been the plague of software development more or less since at least the dawn of the web age, if not before. I'm Falcon, used to be in pen testing, not anymore, and now I manage product security for this little cloud data company called Ivan, Ivan.io. We make managed databases. You can move them between clouds by a click of a button. It's really quite awesome. I love it. It's nice to be in-house. Intermittently, I still do a whole bunch of research on LangSec. This is sort of part of it, postulating things and hoping. And of course, I've finished the master's degree I used to introduce myself as a student of before. Anyways, so input sanitization. We talk a lot about input sanitization. It's been a long-standing frustration of mine, more or less every time that I talk to somebody, hey, what do you do about cross-site scripting? And usually in the context of something like a job interview, they're, yes, cross-site scripting is solved by input sanitization, purely by rote. You know, this question, this answer all the time. And I think input sanitization is perhaps sometimes the wrong tool for the job. A little bit like trying to clean up the beach or your carpet with a floor mop, or brush a laptop screen off with a coarse nylon brush. It's not necessarily going to work. It's kind of a crude tool for what we're really trying to do. And I want to talk today about offering some alternatives to that approach, because I think we can do a little bit better than that. Most of the approach of language theoretic security is about making our code very easy to verify and then verifying properties of it. You'll recall that we talk a great deal about limiting the complexity of systems. This is really just part and parcel with that. So input sanitization doesn't actually stop injection attacks. We know that it doesn't. And I'm so sorry if you're one of the folks that was taught this over the course of the past 2 decades of information security, because, yeah, oh boy. Is any input inherently dirty or clean? Is this bad, this input? Do we want to make values judgments about these strings? Well, they're here on my slide, and no exploits are popping, so it can't be that the strings themselves are the thing that is bad. And these strings are kind of their twins. What if I want to talk about the JNDI exploit? How am I going to do that without actually saying the JNDI exploit? Do we really want a product like a web application firewall in between you, the users, and something like Stack Overflow preventing you from saying the swear word? Is that really going to help? But we kind of have been thinking this way. Right? You think, well, if I'm going to prevent cross-site scripting, if I'm going to prevent this particular class of exploit, I'm going to do so by sanitizing my input and making sure that the bad exploit strings don't make it into my application. This is why the subtitle of this talk was Reconnecting the Corpus Callosum. We're kind of of 2 brains about this. And it's really necessary to integrate our thinking a little bit more about this. Stop this reflexive response that isn't really necessarily as well thought through as a well-architected control might need to be. So if we can say these things, if we can talk about these things, if we can have strings that are of this form and it's perfectly safe, the thing that matters here is not the strings, the thing that matters here is the context. Right? So all of these various things, depending on one context, they might be vulnerable. Or they might be an exploit, they might be a payload. Depending on another context, they might not be. And what we have to really do when we're trying to secure a system is understand not so much the definition of valid input, we do have to understand that, but we have to understand the definition of valid input in each of our contexts. And the context about which we care most when we're trying to prevent injection attacks is that layer between the data that I have in my backend, the data that I have in my data store, the data that I'm accepting from you, and the next place that that data goes. That's where the definition of security is. So don't attempt to create universal, safe subsets of arbitrary data. We can talk about this kind of as, what do I want to say? We have these sets of characters. And again, I was saying earlier, there's no bad strings, there's no bad characters. I've seen altogether too many times specifications for things that say only put plain text. Don't put any of them hacking characters in here. Well, these are all hacking characters in some contexts, but not in others. My favorite one, the example on the far right of there, of course, is valid SQL. It's executable, I suppose. But really, it's just, it's something that you might say. You might write this down. You could type this out in a message to your friend, and it would make sense. It's normal, readable English text, even though it's also SQL injection. It's also not a problem in HTML. And so the only thing that really matters here is the output context into which this is going, which leads us to the answer here is not input sanitization. The answer here that we should be concentrating on and investing all of our effort in is output encoding. Commonly used characters in neutral language are commonly used characters in neutral language until they go somewhere. The reflex that we often have when we're dealing with untrusted user input at scale is to say, okay, let's grab the user input and we'll encode it into something that we think is safe. Let's say we'll take our string and we'll run it through the HTML sanitizer so that we've scrubbed it off. All those hacking characters are gone. Now it's HTML. There are two fundamental problems with this. One of them is that, as you can see, this isn't that wholly, ultra, perpetually safe ASCII, A to Z uppercase, A to Z lowercase, 0 to 9, and whichever punctuation I feel like today. It's not. It's full of ampersands. It has syntax. It turns out that its length on the wire is different from its number of characters, which is one of the favorite properties of people who like to find a very special subset of injection attacks, buffer smashing exploits. It's also a little bit awkward, difficult to read. Natural language parsers might not necessarily have the best time with this. Why is this word amp appearing so much in this text? Well, if I ran it through a naive natural language parser, just to make a straw man of this here, really it would think that the text is about something like electrical engineering unless it was aware syntactically that the string ampersand amp semicolon actually was just the word and. So you really don't get safe subsets. What you really get is syntax. Everything has syntax all the time, and everything that reads something has to understand what that syntax is in order to be able to process it accurately, or you will end up with results that are at best wrong. And as we know, results that are at best wrong, well, the whole point of being red team is you're in the job of manufacturing bad luck. So why are we doing this? Why do we want to take random strings that we're inputting from the user and run them through an HTML encoder and then put them in a database? When I put it that way, is that a flow of processes that somebody would design and call a well-architected system with good design rationale? I probably wouldn't. But you do this a lot to try and make it safe. So let's put this into the context that I've been kind of alluding to. One of my favorite contexts for input handling is I've got some random review website. Because it has one of the things that are fairly difficult to do with input sanitization. It requires that the data has some degree of formatting attached to it. And this some degree of formatting has been the consistent bugbear of web forum software, review sites, anything really that stores user-generated content is, well, we would really like people to use bold and italic and stuff. Many just elide this completely. I know that there's lots of reviews that you just can't do formatting because it's dangerous and difficult. Well, it does. It is difficult. It requires a little bit of design. So let's take a look at this website. The input that I've chosen 4 cases where this input must be treated differently. The first one is this user input. The user has some declarative specification. Limited formatting is allowed. We know what limited formatting is allowed, I hope. All tags must be closed. If you don't close your HTML tags, you get an error back. You have to correct it because of the input filter. Okay, we're good. So the point of doing that, typically, the reason that we do this limited definition of input and validated is so that when it comes time to display this stuff, we can just yeet it right out into the template HTML and all, templating by string concatenation, unparsing by string concatenation. Primitive usually works, it's kind of okay, and we need that formatting for user engagement, so we better allow it. Well, if your controls are getting in the way of the business objectives, I submit that they're probably bad controls. So we're gonna allow formatting. But then we have these other two use cases beyond user display that we may not have anticipated at the beginning of the existence of our software suite that takes the stuff in and displays it. Well, before we just stored and retrieved, but maybe later on we'll want to mine the data. Well, now again, we have to worry about that stupid keyword thing, and now our data mining has to understand HTML. Why? And then, of course, the last thing, legal holds. What if some business wanted to dispute the review that was left of them, and we need to find every mention of them in our software to figure out what our position is? Those three strings, business A, business XML entity non-breaking space A, and business expanded French quotation close mark A. Are these the same business? Are they a different business? Who knows? Which ones of these should be output? Will we get them all? Will we be able to anticipate every possible interposing string that goes between business and the letter A? I don't really want to do that. I don't think you really want to do that either. It's a guarantee that you're going to miss something. So this is why it's important that we make deliberate choices. I also want to kind of call this out because there have been a few cases about this recently in the Pacific Northwest. This Squamish language orthography contains the 7. It's a glottal stop. Kind of like an apostrophe in some other script. Some folks in BC, a Squamish family, tried to name their kid this. I'm not going to butcher the pronunciation. I don't speak the language. I shouldn't even try. But the point of it is they couldn't because it has a 7 in it. Don't make up rules that aren't real. So one of those rules is HTML. It's perilous to make up the rule that all input and output should be HTML. It requires you to import this huge amount of understanding. The other thing is if you make what we might think of as a common sense rule, names include only A to Z, they maybe start with a capital letter, maybe they're all case insensitive. That's just not true. And it's been causing a lot of problems with people having to rename everything from their company to their children in order to fit into a security person or an application developer's definition of what constitutes a valid string in a language. So it's more complicated than you think. Don't do this. And in particular, we already know all of this to be true in the context of passwords. You already know that if somebody is saying your password can't include any of this following list of special characters, what the heck are you doing with the password, right? So you already believe that input sanitization doesn't work. So this is the solution, output encoding. You already do output encoding, and I'm going to breeze through this so that I can concentrate on the examples. You already do output encoding because you already use parameterized queries. You already use output escaping libraries. You already use streaming encoders. So parameterized queries, of course, the way it works under the hood, typically there's a wire format by which you're making your SQL queries. It might actually just be SQL. The library normalizes out whatever strings you take in. You pass it something in your programming language. It transcodes that into the wire format and goes. It's completely transparent to you. It's encapsulated. That's awesome. We're separating concerns when we do this. Output escaping libraries, the same way. You might notice that there's an output escaping library for HTML, there's an output escaping library for XML, there's an output escaping library for JSON, and you need to use the right one for the format that you're in. That's literally just output encoding. And of course, streaming encoders and things. Let's stream this markdown out into PDF. We're output encoding. And the awesome thing about this is you can very easily show if you're writing out to a format that what you're writing out is that format. You don't need to be worrying about, hey, did anybody ever manage to get anything into my backend at some point that can't be validly concatenated into this particular point in this particular template for all templates that exist in the past and future? That's not encapsulation. It's not even testable, really. So yeah, output encoders are nice. They're fuzzable. You can test them and ensure that everything that they generate is actually valid. They're provable. You can generally verify them if your output format is simple enough. You can certainly show that something outputs valid XML for the subset of XML that people actually use. For instance, it's very easy to show that these can only output valid SQL or can only output valid JSON. And you get to choose the complexity based on the output format that you're willing to encode into, just how difficult or complicated your output encoder will be. The output encoder is also encapsulated. The thing that the output encoder encapsulates is a definition of what breaks the break between data and signaling in the output format. What constitutes valid or invalid can all be contained within that boundary. Leaves us the question of what do I actually store in the database when I do this? What do I take in? How do I transform that? You've got to do it twice. There we go. Okay, the example. You've got to do it twice. You've got the user wants to write this SQL statement. The user writes a saved filter like select star from customers where country is Canada or Finland. And we want to store a canonicalized representation of that if at all possible. You can also store the string kind of for display, but what you really want to do is you want to canonicalize it. This helps you in a few ways. It helps you compare it later. It helps you answer questions about it. It helps you make it kind of independent. If you do this, if you take the SQL and you parse it into this intermediate language canonicalized representation that I just kind of made up in 5 minutes, it translates like this. It's the same as the SQL. Select, and then we'll OR two things together. Field 1, ISO identifier Canada, or field 1, ISO identifier Finland. Field 1 in this case corresponds to country. And this kind of stores the string. It's kind of it's a hack job. You would have to do a little bit more detail than this if you were doing it for real. But the point of generating this kind of intermediate representation, this is the way that basically all compilers work. You compile your C into an intermediate representation, IL of some sort, and then you write it out into the binary format for your target architecture. We can actually do the same compiler technique with basically any type of data, whether it be formatting or whether it be SQL. Once you've done this, you have a few advantages. One of them is that you can write it out into SQL that you know is safe, because you can say, well, my transformations from this only generate SQL of the form that I was looking for. The point of this was, maybe I went too fast through it. We wanted to allow the user to determine which table they were selecting from and what predicate they had, but not more than that. We didn't want them to join other tables together. We maybe want to restrict the names of the tables that they could access. This is beyond what parameterized queries could do, which can only do the parameter part of this, not say what are the table names or how many predicates do we have. You have the advantage that you can actually output and code this into wherever you want it to be. You can write it in ISO SQL. You can write it out as a MongoDB query if you want to. It's the same, as long as you're willing to write that definition. The point of this, our interchange is a well-defined programming language. We can reason about it. You can show what it's going to do, and you know what it's going to do. If somebody injects some garbage into your database, you'll more likely get an exception in your output encoder than you'll get a SQL injection exploit, so that's not injectable. Here's the other example, back to formatting. Let's take our string. We have a heading. We have a line break. It has a little bit of syntax in it. If we transform it into this representation, and there is a paucity of these representations, we need to make more of them. I wish I could say, just use this library. It doesn't exist yet because this isn't as common a technique as it should be. You want to basically write it as, this is kind of a JSON-like representation. You can pick something like that that you can very easily show is correct and well-formed, and you can throw exceptions if it's not. Make your own keywords. Try and make them so that the representation is as unambiguous as possible. Then we can do our permissions check on it. Is the user who wrote this allowed to use the H1 operator? Much, much, much better than having a regex that tries to filter HTML input, which we know is a technique that doesn't work because HTML is not regular. When it's time to write it out, again, we can choose our output formats. Our interchange format can be stored in the database safely. Of course it can. We can serialize it out to strings that can be stored in the database using a different output encoding library. And this is what protects us at the boundaries. So in a very short summary, the thing that we ought to be doing, rather than trying to sanitize input and prevent people from sending us exploit code, is try to make sure that when we write it out, the thing that is doing the writing out is not naive like a string concatenator. It actually understands what it's writing it out into. You can verify what it's going to generate and what it isn't, and you have verifiable code. Congratulations. Just have a little time for questions, I think. Yeah.
It's really either or, though. I mean, there is still some benefit to some forms of input sanitation in the right context. So if you have a context that lends itself to input sanitization,
The question being, isn't there still some role for input sanitization in short? I would say that we only have a finite amount of effort to spend, for one. I would probably rather see that effort go into writing verifiable output encoders than writing signatures for exploit code. I think that I've had this conversation a few times when I've talked about this control, and I think that the biggest argument that I can make in favor of input sanitization really is that an XSS payload is probably spam. It's probably not topical. If you're in one of those contexts where it doesn't make sense, certainly filter it out because it's spam. But I think that fundamentally speaking, there's very little input in a well-architected application that really needs to be subject to it by being inherently bad. And it's kind of a special case factory. What if I want to allow my forum users to talk about cross-site scripting? I have a special case if I'm doing input sanitization, and that's kind of what I'm trying to avoid. Mm-hmm. Okay. If nothing else, I think I'm being told to get off stage and shut up. So thank you again, and see you soon.